All right, so what we're looking at here is synthetic division. And synthetic division is super awesome some of the times, and sometimes it's completely worthless. So synthetic division works great when you have a polynomial divided by something like x minus a, or whatever, some number. It also works if you have a polynomial divided by x plus a, or again, a is just some random number. In this case, it's awesome. There are other cases, however, say you had some kind of a polynomial divided by like x squared plus 1. This would not work. If you had some kind of a polynomial divided by, say, x squared plus 2x plus 5. No, would not work. I forgot the smiley face guy here. All right. These make us happy for synthetic division. These make us sad. The only time you can use synthetic division is if you have this, well, at least in the case, the way we're describing here, the only time you can use this is when you have this like x minus a thingy on the bottom or an x plus a thingy on the bottom. So this is what you want to look for. So we'll do a couple of examples here. For one example, let's try 2x squared. 2x squared, let's see, is that what I want to do? No. 2x cubed. I like 2x cubed. We're going to 2x cubed minus x minus 13 plus 6, and we're, oh goodness, I'm going crazy. X squared, 13x, there we go, plus 6. Let's make that a plus, oh, for whatever reason. And then go x minus 6. So we randomly pick some numbers. We're going to see what happens. This could be catastrophic. All right. So in that synthetic division, we check, okay, we have a polynomial on top. Yep. And the bottom is in the right format. It's x minus something or other. Yes. Alrighty. So we're ready to go. So basically, we're going to set up a little problem here. We're going to take the coefficients off of each of these, let me try this again. We're going to take the coefficients off of each one of these, and we're going to use it. So I've got a 2 here. I'm going to put it here. I've got a -1 for a coefficient here. I'm going to put a 13. That's my coefficient there. And then I have this coefficient, 6. Well, it's not really a coefficient, just my constant. So I got my constant. Now notice that all of these are going in order. So I have x cubed, and x squared, and x to the first, and then your constant term. If these weren't in order, we'd have to put placeholders, just like you do with long division. So just keep that in mind. Then what we do, say, okay, well, we have x minus 6. So we have that little x minus 6. We're actually just going to pick the 6. So if this is minus 6, we use 6. If it was plus 6, we'd use minus 6, which is totally weird, right? Basically, we're going to use the opposite of whatever this is. So we've got minus 6, so we're going to use plus 6. We're going to draw a little box around it. So what we're going to do is pretend to divide, which is kind of silly. We're going to pretend to divide. So the first step we always do is we're going to bring this first term down. So it's now a 2. All right. So what we're going to say is, okay, well, what is 6 times 2? 6 times 2 is 12. We write it there. Choo, choo, choo. And then we're going to add it. So we've got 12, or -1 plus 12. So 12 minus 1 is 11. All right. 6 times 11 is 66. And this is what happens when you make up numbers. 6 plus 11, or 6 times 11 is 66. And so we add that straight down, and we get, that's a 9 and a 7. And now we have to multiply it again. 79 times 6, 4, carry the 5, that's 42, right? Yeah, 42 and 5 is 47. So 474. This is a little silly now. And we're going to add these straight down. So 474 and 6 is, thank you, nobody cares. 474 is 480. Plus 6. Yeah, 480. All right, so now what we've got here is we've got a 2 and an 11 and a 79 and a 480. All right, this 480 right here is our remainder. This 79 is our constant term. So since this is a remainder, what we can automatically do, stick a plus sign in front of it. Well, not maybe right there, but this remainder is going to go over our divisor, which was that x minus 6 thing. So we have a remainder over the divisor. So that's going to be eventually plus that. We'll put a box here. Wait, that's not what I meant. We don't put a box there. We're just going to leave this as it is. That's our constant term. So plus that. We're going to put a box here and put a box here. And really what we're going to do is we're going to work backwards. So we're going to just fill in stuff. So this is our remainder. This is our constant. So this has to be an x. And then this one has to be an x squared. Okay? Because we're always going to have a remainder. We're always going to, well, maybe, but we're always going to at least have a spot for a remainder. We'll always have a constant or a spot for one. And then each one of these is going to represent an increasing order of x. So x squared, if we had more, it'd be x cubed. So this way, now we can write out our solution, which is 2x squared plus 11x plus 79 plus 480 over x minus 6.